Okay, we were discussing about the stacks in the last class, right? Um, what did we actually discuss is that how that is what is a stack we have discussed, and then we have completed the stack implementation of stack operations using array, right? And also I have explained you regarding how it is going to be through the what is it called? Um, Yesterday we were discussing this, right? We
Yes, sir.
stack. Can you see?
Yes, sir. Sir.
Right. Stack implementation using linked list. We take a pointer pointing to the node called top. That is start pointer can be the top here, which is initialized to null. And whenever a new node is created, right, whenever actually new node is created means a uh, element has to be inserted or pushed into the stack, right? So what are we going to do? Then the new node has to be inserted in the form of a first node. So the first node logic we are going to follow, right? So this is what we have discussed in the last class, right? Okay. So right. And similarly, when we are talking of the pop operation, then we need to delete the first node, so that the top now next points to the next node that becomes the top node. Okay. So now let us write the program that is function for this. So I'll write only the functions now. Okay. So simply void today's date is 1st May 2021. So I'll take void, okay, uh, push, void push, okay, right. So what is that we require? I already remember what is that we have declared. A node has been declared, same as linked list, this one, right? Okay. So node has been declared, and we have taken it as what is that called, type def, and so we are using only the single linked list, my dear friends. Okay. So I'll say node star. So node star new node I have to take, new node. Okay. Remember what is that I have taken instead of in the what is that called, in the global declaration. We have taken not start, but I have taken that is as top. We have taken it as top. Okay. So or otherwise you want, I'll write that first initially first time I'll write, next time onwards we'll stop. Okay. So first time I'll write okay, ash include, I'll not write the main. Okay, main is same as your array. Okay, right. So ash include this. So there's no ash defined, not required, because we are not implementing by this. We will have the functions. So first of all, let us define type def struct. I'll say stack is the name. Okay, stack is the name. Int data, and again struct stack. Okay, I can say link or ptr, we are using star ptr. Okay, star ptr, and I'll say the name this as node. Okay. So and now deploy the functions void push, void pop, and void peep, peak, void peep, and what does int is right, int is I'm not going to check for is full will not be here, right? Only is empty I'm going to take, is empty, Okay, right? All right, and then declare the function int n is equal to 0, basically to number of nodes, right, are not required. Okay, that is, without that also we can do the problems. And what else is required? Node star top is equal to initialize to null.
Null.
This is very important. Okay, right. So that's the end of the this one. And now write the void main. So void main is same as your what is that called? What we have done earlier. Okay, so is this clear? So what are the functions we have? Type def struct stack we have taken into data, struct stack star ptr. Okay, so that a single linked list is going to be formed. Okay, so let us go to the next page now and write the uh,
Sir, one second.
yeah, what happened? That is, I'll show you once again. Okay, it doesn't matter. First, let me complete this one. Now onwards, you please write void push. I require an int data item to be pushed. I require node star a new node. So we are pushing is going to be done, right? Okay. So I'm going to take printf. I'll say enter the value to be inserted or to be pushed. Let us store that in percentile d, right? Ampersand data. Now create the function. Create the block. So
Associate node.
new node is equal to node star
Malloc
malloc
size of
size of node. Now, does it compulsorily return a this one? Tell me. Does it compulsorily return what is that called? A pointer, or can it return a null pointer? When does it return a null pointer? This new malloc function. When the block of memory is not available, it cannot be, operating system could not allocate the block of memory, then what is going to be returned? It is going to return null. So if the new node value is null, then that means that sufficient memory is not available, right? So first thing what I'll do is if I'll check new node is equal to null. If new node is equal to null, then I'll say printf, right? Memory not allocated. Memory not allocated. So your pushing operation cannot take place. Your pushing operation take on. Else memory is being allocated. So I'll go for the pop operation, a push operation. So what is the push operation we have to do first? A new node has been allocated. So we'll say new node arrow. What is that part? Data part is right,
this data part.
is equal to, here also I've used data,
Data.
right? Right. So if you want, you can use this as val so that you there will not be any confusion. Val I'll use. So this is going to be val, and this is going to be val. Okay, right? Uh, so now new node. One more thing. Arrow PTR should be equal to what? Null. Initialize to null. Okay, right. Now, how do you know that this node which has come up, actually what happens here is the new node which has come up is to be added in the, it is in the top, right? Top means it is the first node. It is always the first node. But if the list is empty, then this is the first node only. This is also the first node. But what is the difference you have? The PTR, whatever the new node arrow PTR will be null only, right? Okay. So that is what is the difference you are going to have. So first thing you have to check is what you have to do is whether it is the first one or not, right? Okay. Now when what is that actually this is what is the top. Let us take. Okay, this is the nodes which are there, for example. So a new node has come, right? So what will happen? This is 3186, for example. This is 3186. So what will happen? This 3186, whichever is there, will be
New
now
node arrow PTR.
Neuro arrow PTR. Are you getting the point or not? Okay.
Yes, sir.
So what is the top value? Actually, top value
New
is
node.
what? New node. No, no, top value is new node. Before that, new node arrow PTR is
Sir,
equal
equals
to
to
top.
top.
Is equal to top.
Yes, sir.
And remember, for example, if it was null, if it is one null, this top was equal to null, then what will happen? Now tell me, top value is null means it is empty.
Yes,
Then
sir.
also new node arrow PTR is equal to null only. Right? New node arrow PTR is equal to top means it is null only. Yes or no? Right? So you need not take if top is equal to null, then there is a separate logic for it. Both our logic are going to be the same. So directly first step, what I'm going to do is new node arrow, right? Arrow what? PTR is equal to top. Actually, this step is not required. New node arrow PTR is equal to null is not even required for us. Okay, right? That is not even required. Okay, this is not required for us. Directly new node arrow PTR is equal to top, and now change the value. Top is equal to new node. Top is equal to new node. That's all. And do n plus plus. Why? Because you have added a node. That's the end of the push operation. Now you see any doubts in the push operation?
Sir, can you say once again that logic, sir? Up to new node arrow
For
data under
example, this was, let us take, this is top. This is null. What does this mean? The
empty, sir.
list is empty. If the list is empty and the new node has come, for example, this is the new node which has come. New
Yes,
node
sir.
which has come, right? So whatever is coming, the new node, I am new node arrow PTR, I am taking new node arrow PTR is equal to top I am doing. So what would be assigned now? New node arrow, therefore what will happen? New node arrow PTR would be
PTR is equals to
null.
null. Yes, sir.
In this particular case, suppose that it is not what it is
First.
assumed that this is having this one. Okay, right? Now top is 3186 means 3186. Now it is not null. But then also what will happen when I'm assigning the new node arrow PTR is equal to top, then 3186 would be here. Yes or no? So the link is established like this. And new node address is going to be, for example, 2832. 2832 is going to be overwriting here. So in
Okay,
both
sir.
the cases, I should say that top is equal to new node and new node arrow PTR first step. If you do it is equal to top, then automatically that is going to be the one. Is this clear? Right? So there is no last which is being maintained. Now here this is
Yes, sir.
last is not required. Only the one pointer is required.
One
That
way.
pointer is stop. Okay. So this is what is your push operation. If you should have made a note of this, then we'll go for the pop operation.
Sir, but this condition execute only once, no, sir.
This which one?
This void push, sir. Only once it will be executed, no, sir.
Yes. Again, no. Whenever you want to push an element, you will you are doing it in main.
Yes,
It is
sir.
not create, right? Okay. I will do it only for once. Okay, because if you want to do the second time push operation, you'll once again call the function in the main. Main only you in the main you have given now. Would you like to continue or not? As defined. Where is that main function? Did we write that main function? Yeah, this is the main function. You see?
No, sir. On the
Yeah,
next day, you wrote another main function.
the same thing. You this was outside, yeah. Okay, this was a push, pop, right? These were the this one printf enter your choice, and switch case we have used first is push, pop, right? Only this part would be outside. That's all. Okay, right?
Yes, sir.
So that what this part was actually there. So the other one what I have written on that day was this
Functions we wrote, sir. That's it.
functions. Before functions, you see, right? This was written outside. Okay,
Yes, sir. Yes, sir.
right, the same thing. So let us look at this. So push, pop, peek, peep, exit, enter your choice. You are taking the choice, and switch case you have used. In the switch case, at the last, what are we doing? While ch, would you like to continue? Yes or no? So push
Sir.
operation is going to be done once. You element once. In push you will not ask would you like to continue and more element. No, we will not do that. Okay, right? That's not correct. Is this correct? That implementation is not like that. So this is what we have written today. First, this is what, yes, right? Okay, you can make a note of this, and thereafter this is what. First you make a note of the main function, so the remaining main function is that only. Okay, same switch case you are going to use. And this is the push function. Remember, this is very important. If new node is equal to null, it is not top is equal to null. If new node is equal to null means then the block of memory is not being allocated by the operating system, right? So you cannot push the element. Okay, so that is the reason this check is very much required. Okay, till now we have not done, but every time you need to check this. If new node is equal to null, then memory is not allowed allocated, right? Else you are doing new node arrow data is equal to val you are taking, and directly new node arrow ptr is equal to top, and top is equal to new node and n plus plus. N plus plus is basically if you are taking the n. If you don't have n, then that is also not required. Okay, number of nodes not required. Okay, without n, assuming that n is not available, then how to do that also we'll do it. Okay, next. So now let us go for the next one is we are going for
Pop.
what? Uh, Let us go for the pop operation. Why pop? You require an int val to store, right? And you don't require a new node, but you require a temporary node, temporary this one temp, so that you can assign temp is equal to that top, and then release the temp. Don't say really free top. Free top means what will happen? The complete
All.
link would be lost. Complete
Yes,
link
sir.
would be lost. Okay. So what is that we are doing now here? First thing is that I have to check for is empty. I have to check for is empty, or otherwise is empty. I'll not write a separate function, right? Directly I'll check for if top is equal to null. If top is equal to null, then printf stack is empty. Stack is empty. So there is no question of any deletion. You cannot pop out. It is empty. Else part you can do the popping, right? You can do the popping. So how that is else? You have to assign first temp is equal to top. Assign top is equal, right? So for example, this was your this one, right? So this is top, and the number, this is 3186, for example 3186. So take temp here first. So temp is equal to 3186, it stands. Now free temp, You're before freeing the temp, what are you going to do? This particular second node address is stored in first node
temp
PTR,
arrow PTR.
right? So temp arrow PTR or it is top arrow PTR. So you are going to say top is equal to now top arrow PTR. Change that. Okay. So top is equal to top arrow PTR. So that you have broken the link and you have established the link with the second one has been established here. Okay. And if it is only one node, what will happen? The first node PTR should be will be equal to null. So automatically top will become the null now. Okay. So top is equal to top arrow PTR, and very important val is equal to uh, temp arrow data. Don't forget that. Now you say temp, free temp, and if you are using n, do n minus minus close. Right now what you can do is you can write here before closing, you say printf popped value is percentile d slash n, this is val, popped value, and then close the else. After else, close the void pop. Is this clear? What did we do here? First we are checking for top is equal to null, then printf stack is empty, so deletion is not possible. Else temp is equal to initialize to top temp is nothing but top, the first node, because the first node has to be deleted, right? That is the top node. Okay. So top, and then val is equal to temp arrow data, you take it. Top, you change it value, top is equal to top arrow PTR. So this top arrow PTR or temp arrow PTR are one and the same, because temp and top are both are same. So what is going to be top arrow PTR? It is a second node address which is stored in the first node PTR. Okay, first node address field. So the first node address, when we are deleting the first node, then second node becomes the first node, right? That becomes the topmost node now. So when, how to make this as the topmost node now? This address has to be stored in the top. So what are we doing? Simply whatever is stored in the address field of the top arrow PTR, that you assign it to top. So top is equal to top arrow PTR, the val is equal to temp arrow data, and free temp, and n minus minus is to reduce the number of nodes, and printf popped value is percentile d slash n val close. So this is what is your pop, right? Is this clear? Now let us see the next one is void peak. What is peak? Printing the topmost element. Okay, topmost element. Now tell me if now I'm going to check for if uh, top is equal to null. What are we going to say? Printf stack is empty. Stack is empty. So there is no what is not available for you? No topmost element. Else, what is the topmost element? Now tell me, printf directly, right? Topmost element, right? Topmost element is percentile d slash n. What is this topmost element? It is nothing but top arrow data, and close. Is this clear? Right? So this is a peak. This is peak. This peak. Now let us see peep. Peep is printing the elements. So from where are you going to start? From top only we are going to start. Okay. From top we are going to start. That is the first topmost element. So I'll go to the next page. Void peep. Right. Now for moving from one node to the another node, you require a temporary node. Yes or no? Otherwise we cannot do, right? So for example, you were having, right, let us take, this is one top and another node, another node, another node. And this is what value? Null. Okay. Now temp has started here, temp will move to here, temp will move to here. Okay, so when temp has moved from 1 to, and remember I'm not having the tail or the last, I'm not assume that the number of nodes are not maintained, number of nodes are not maintained, that is n is not known. Then how to solve this problem? While condition. First, this is temp arrow data is going to be printed. Second time temp arrow data is going to be printed. That means I'm going to use in the while, what is the condition I have to check? I have to printf what temp arrow percentile d, I have to print t temp arrow data I have to print. That's all. I have to print this, and I have to take temp is equal to temp arrow ptr. I have to do it. This is what is to be done in the while. Okay. Now the point here is when I'm doing this in the while. Okay, what is this while condition? This is very very important. I don't have. I was when we were using the number of nodes n, I would have taken I is equal to 1 and y less than or equal to n. We would have done, but I am not using I now, or n is not there. Assume that this are not available, right? Extra variables not available. Then how to go about, right? That is, remember that this is a, there is a value here, there is a value here, but here in the last node ptr it is null. The last node ptr is null. So when temp has reached here, what is temp arrow ptr? What is temp arrow ptr? Tell me. Come on, please speak out. What is temp arrow ptr? Yeah, please speak out. What is temp arrow ptr when you have reached to the last node? Everyone.
Also,
Null.
Null.
It is
Null,
null.
sir.
It is null. So when temp arrow ptr is null, the temp has reached to the last node. That means it has to print. It has to print. Okay. But when temp is equal to, that is temp is equal to temp arrow ptr is being done, then when it is reached to the last node, when temp arrow ptr value null is assigned to temp, then temp becomes null. That means after that there is no node. So what should be the condition here? When temp is not equal to null, right? It has to do, when temp becomes null, it has to stop. It has to stop. So very simple. I'm going to take node star temp is equal to initialize it to top. Initialize it to top here itself, right? Now what are we going to do? While temp uh, is not equal to null, temp is not equal to null. Before that, what is that required? You have to check whether it is empty or not. If top is equal to null, top is equal to null, then printf stack is empty. So you can, there are no elements to display. Okay. Else you are doing the display part. So what are we doing else? Initialize the temp is equal to top, we have already displayed. While temp is not equal to null, temp is not equal to null, what are we going to do? You printf percentile d slash t temp arrow data is going to be printed, and after that temp has to be moved to next node, that is temp is equal to temp arrow ptr. So temp arrow ptr, then it moves to the next node. So in this way you have printed all the nodes. So while is closed, then else is closed, and then void peep is closed. Now, did you see we have not used the I or N, but we are able to do it. Understand the logic here. Temp is not equal to null. For example, if it was only one node, first node temp is not equal to null because only one node is there, top value will not be null. So if top is equal to null means it is an empty. If top is equal to null and there is only one node, for example, what will happen? Temp would be not be equal to null. So it prints the value, and thereafter temp is equal to temp arrow ptr means temp arrow ptr would be null because it is the null, one node. Then temp, that null is assigned to temp, and when it goes back, then temp is not equal to null is not met, and so it comes out. See how you are able to print the this one, or remember in the this particular linked list, if you don't have the last, or if you are not using, for example, if you are not using the number of nodes and I is not required to be used variable, then we can go by this particular this one, that because it ends with what a null pointer, right? So we are going to check the condition for not equal to null. Okay, that way we can solve this particular problem. So this is what is your stack. Okay, so then the next class, what we do is, I'm going to, on Monday I'm going to go ahead with stack applications also of this. Okay, stack applications, yeah, we are going to do, right? So now what I'm going to give you is, I'll dictate a or I'll write the what is it called, there is a algorithm, okay, which you are going to make a note of it, right? So make the note of the algorithm, and after that, on Monday we are going to work out on that particular algorithm. We are going to do the problem. Okay, write down infix to postfix expression evaluation, sorry, infix to postfix expression, conversion of infix to postfix expression, conversion conversion of infix to postfix expression, conversion of infix to postfix expression. Okay, so write down the step by step, that is, I'll write algorithm. After algorithm, I'm going to take out the example, but I will not write the program you have to write. Okay, so the step one involves the expression is scanned from left to right, one at a time. The expression is scanned from left to right, one at a time. That is one symbol or one character at a time, right? If a number is encountered, it is pushed onto the stack. You also please make a note of this. Third, if an operator is encountered, it is applied. What are we doing this? Actually, I'm sorry, you are, we are, this is not conversion. This is evaluation of postfix expression. This is evaluation of postfix expression. Okay, so please make a note of it. Evaluation. If an operator is encountered, if an operator is encountered, if an operator is encountered, it is applied to the top two operands on the stack after removing the operands used, the result is pushed onto the stack. Very important, note that the operator is not pushed into the stack, to the stack. This is very important. Okay. Then the above steps are repeated until the end of the expression is reached. The expression is reached. Now the top element, of course, remember the top element, right? Of course, I should say that the stack contains only one element at this time. The stack contains only one element at this stage. At this stage of stack is popped, which is the answer, which is a result of the expression, which is the result of the expression. So this is algorithm. Step one is the expression is scanned from left to right, one at a time. That is whenever it is coming. We are going to take example and do it. Don't worry. First, make a note of this. Then second, if the number is encountered, then it is pushed onto the stack. Third, if an operator is encountered, it is applied to the top two operands, or operands means numbers on the stack. After removing the operands used, the result is pushed onto the stack. Note that the operator is not pushed into the stack. This is very, very important. And the fourth step is the above steps are repeated, right, until the end of the expression is reached. Right now, the topmost element, of course, it is only the one element which is going to be there in the stack, right? It has to be, if it is not one element, if it is more than one element, then something went wrong somewhere. Our stack is popped, which is the result of the expression. So this is what is the what is that called, the operator what is it? It's a expression, that is evaluation of postfix expression. Evaluation of postfix expression. Okay. And next, please write down the in algorithm. Next algorithm is conversion. Conversion of infix to postfix, right? Okay, write down conversion. Oh, sorry, not to conversion of infix to postfix expression. So we are going to see in the next class. I'm going to tell you once again. We are going to revise what is infix expression and how to convert it into that postfix. We are going to follow the algorithm, and also I've told you one more method of layman method. I've told you in the semester one during the PPS class, how there is how to get a postfix expression. So that also once again I'll revise for that also. Okay. So now let us write the what is that called, conversion of the infix to postfix expression is when an operand is first is step one, that algorithm will let us write. Step one is operand means, for example, a plus b. Operand is a, operator is plus b, a plus b. If you take what is operand, a and b are operands, and plus is an operator, right? So we know this. So when an operand is the infix expression is scan from left to right at a time. That is what. So I'll say that scan from left to right, left to right. So the scanning continues till when? Till you encounter the that is the last that is till the expression is completed. When the expression is completed, it is simply by taking slash zero. It is a string. Expression is nothing but a string. So a string is terminated by using a slash zero. Okay, that is what we have to keep it in mind. So let us now take when an operand. First step is when an operand is encountered. Is encountered, it is immediately placed onto the stack, onto the sorry onto the output, onto the output. This is very very important. Operand is always onto the output. Only operators go into the stack, right? So now there is some more called left parenthesis. When a left parenthesis is encountered, it is simply pushed into the stack. It is pushed into the stack. Okay. Then when a right parenthesis is encountered, what will happen? Right parenthesis, parenthesis means bracket. Right parenthesis is encountered. What are we going to do is pop the complete stack, pop the stack and append or add, I can say append or add the symbol or the operator, whatever has been popped operator to the output, output till when, till the left parenthesis is enclosed, left parenthesis, left parenthesis is encountered in the stack, encountered in the stack. The after that is the left parenthesis is then, the left parenthesis is then popped out, popped but not added to output, added to output. Remember the postfix expression or prefix expression does not contain any brackets. Only our infix expression contains the brackets. Okay, right. Number 4, after that, when an operator is encountered, when an operator is encountered, what is going to happen? Is encountered A. Let us take A. Repeatedly, start repeatedly means you keep, repeatedly means repetition, repeatedly pop the stack, pop the stack and add the, and add the popped operator to output, output if it satisfies the condition, is satisfies the two conditions. What are the two conditions? The first condition is, first condition is the stack top operator, operator is same or higher precedence, higher precedence than the operator just encountered, just encountered. And the second condition is the stack is not empty, the stack is not empty, right? So the fifth point here is next, repeat the above process till the end of the input string is reached. Repeat above process till end of string is reached. How do you say that you are reached to the end of the string? When you encounter the slash zero, right? That is slash zero is the null character. And then finally pop the stack and add to the output string. Finally, after that end of the string also you reach, then also the stack will contain the operators. What you're going to do is pop out all that operators and add it to the output string, right? Finally, pop the stack, right? And add all the operators to the output, right? Till stack becomes empty. Stack becomes empty. Okay, this is what is your conversion of infix expression to postfix expression algorithm. Okay, so we are going to do this algorithm. I'm going to take the stack and example, and then we'll do that particular algorithm. So I hope everybody made a note of this algorithm. First, you
Sir,
make a
one
note of
minute,
this,
sir.
and the previous one also I'll show once again. You can make a note of it.
Sir, can you say once the conditions, sir, last?
I'll explain. First of all, I'll once again repeat this. I'll explain it in the next class. First, make a note of it. First step is when an operand is encountered, it is immediately placed onto the output. It is added to the output. Second, when a left parenthesis, that is left bracket is encountered, then it is pushed into the stack. It is pushed into the stack. Number three, when a right parenthesis is encountered, you are going to pop the stack and append or add the operators to the output. The popping will take place till the left parenthesis is encountered in the stack. The left parenthesis is then popped out but not added to the output. Number four, when an operator is encountered, A repeatedly pop the stack and add the popped operator to output if it satisfies the two conditions. When are we going to repeatedly pop the stack? When it satisfies two conditions. The first condition is the stack top operator is same or higher precedence than the operator just encountered. So if the stack top operator is same or higher precedence, then the operator which has come up now, we are going to pop the stack, right? Pop the element, and the stack is not empty, right? And stack is not empty. So you will repeatedly you will do the pop operation, right? And add the popped operator to the output if it satisfies the two conditions. That is, the stack is not empty. It should not be empty. If it is empty, can you do a pop operation? You cannot do an pop operation. If it is not empty, then it contains the elements. So the elements which are contained, the topmost element, whatever is the element which is there, you take the topmost element. You take the topmost element. That topmost element, the operator, if its precedence is same or higher than the just came operator which has come from the string, right? Then what are we going to do? Pop the top operator. So the same thing will continue. The next operator again is going to be compared with the operator which has come now. So this will continue, okay, till if the top operator has got less precedence than the one which has come, the one which has come is going to be pushed into the stack, is going to be pushed. So the repeat the above process till end of the string is reached. That is expression is completed. Finally, after you reach the end, remember it is not evaluation of postfix expression that there would be only one element in the stack, which is the result. Here there may be one or more operators which are there in the stack. All are going to be popped out in the order and they are going to be appended to the output. They are going to be appended to the output. So tomorrow we will take the example of, first we'll take the example of conversion of infix to postfix expression. And after that, we are going to take the postfix evaluation, the same example, the postfix evaluation, we'll do it, right, by using these algorithms. Before closing, I would like to revise your PPS, this one, when we have done the infix expression to postfix expression. Assuming, for example, there is an a plus bx by c minus dy plus e by f. Let us take this is an expression. How to write this mathematical expression? This is a mathematical expression. I have to write now C minimal expression. How to write the C minimal expression? We have seen unnecessary brackets. We should not have it, right? Okay. So we'll write it as A plus B into X divided by C minus D into Y plus E by F. This is what you have written. But now let us see A plus B into X by C minus D into Y plus E by F. What gets evaluated first in this? B into X gets evaluated first, and that is what we wanted. But after that, divided by C is going to be done. That is BX by C is going to be done, but that is wrong. We want A plus BX to be done. That is the reason we'll insert a bracket A plus B into X. And then divided by C we wanted to do? No, we wanted D into Y to be done, and C, that should be subtracted from C. So we are going to insert another bracket here, so that A plus bx divided by C minus dy plus, after this, plus E by F. E by F has to be done, and that is where. So this is a C minimal expression. This we call C minimal expression. Now this I am going to convert it into your postfix expression. I'll take first C A plus B into X, C minimal expression only. I'll take C minus D into Y plus E by F. Let us write what is going to be evaluated first in this. Put a bracket for that. What is going to be evaluated first here?
Multiplicate,
B into
multiplicate,
B into
x.
X is going to be done. So B into X, you take a bracket.
Yes,
Okay.
sir.
And after that, A plus BX is going to be done. The bracket is already there. Okay. After that is going to be D into Y is going to be done a bracket. I have taken a bracket. C minus D into
Y.
Y is going to be done next. We have done. And thereafter E by F is going to be done next. Am I correct or not? Right.
Yes, sir.
After that, sorry,
That
first
whole division,
this
sir.
first
First it
division is
is
going to be
whole
done. First this division is going to be done. Okay. And then plus E by F is going to be, then thereafter this addition is going to be done. So these are the brackets which I've inserted. These are all unnecessary brackets, but only if we want to do without this algorithm directly. If I want the answer, I'm doing this. Now let us take one by one. Where does this operator go? So this operator, postfix expression, means it goes to the right. So this multiplication will go immediate to the next immediate bracket. This place will go to the next immediate bracket. This multiplication will go to this immediate bracket, and this minus will go to this immediate bracket. This e will, sorry, this division will go to this particular immediate bracket, and this division will go to this particular immediate bracket afterwards, and this plus will go to this particular immediate. Now start writing from the left hand side. First, don't write any brackets. First, what is encountered? A. What is encountered afterwards? B. What is encountered afterwards? X. What is encountered afterwards? Right bracket has come up. Right bracket after that is what? Multiplication was gone. And on one more right bracket has come. After that, it is plus which has come. Thereafter, this multiplication division has gone to the right. So then came C, D, Y, then multiplication has come up, then minus has come up. Sorry, multiplication, after that minus, and after that one more right bracket has come up. What is that right bracket? Division, then E, F, then I am having a division for this, and then finally the right bracket is plus. This is your postfix expression. This is your postfix expression. This is how you are able to do it without the algorithm. Without the algorithm. Okay. Now can I'll give you an example. Can you do this? Ax plus by, right, minus cz by f plus then e plus e. Okay, let us do this. Come on, write the first c minimal expression here. What is the c minimal expression? A into
ax
x
x
plus
plus
b
b
into
into
y
y
minus c into
minus
z
c
by
into
f,
z by f
only. That is perfect
plus
only,
c
right? Then
plus
plus
yes.
e, right?
Sir.
No, in fact, no bracket is coming.
Yes,
Now
sir.
convert this, right? I have a into
Into
x
x
plus
plus
b into y minus c
minus
into z by f plus e. First is going to be a into x,
yes, sir.
next b into y,
By c into z
c into z,
again division
afterward divided by f. Now
plus a
a into x plus by, this is going to be done, plus. After that minus whatever is there, this is going to be done, and thereafter plus e is going to be done. Now can you write? Come on, tell me. And please see the left hand side brackets and right hand side brackets, are the number is same or not. If I count the left hand side brackets from left hand side onwards, what 1 2 3 4 5 6 7 7 are there. Right hand side brackets you see 1 2 3 4 5 6
same, sir.
7. Correct. How many operators are there? You see, multiplication 1 plus 2, multiplication 3, minus 4,
7, sir.
multiplication 5, division 6, plus 7. Remember, the number of operators should be equal to the number of left hand side, left parenthesis should be equal to the number of right parenthesis. This is what is the simple rule when you have put the brackets. So now start putting it. This
Ax
multiplication will go to the nearest to this. This multiplication will go to the nearest this. This plus will go to the nearest right hand side. Multiplication will go here. This division will
minus
go here. This minus will go here. And this plus will go here. So write down now. A
ax
x
x in
multiplication b
addition
y multiplication plus
minus
c z multiplication, then then
division
then
f, sir.
f
F
f
division
division, right, then
subtraction
minus
e
e plus.
addition.
This is what is your this one simple. Is this clear? Postfix expression, if it is a prefix expression, simply you will take it to the left hand side, that's all. You will take it to the left hand side, it becomes a prefix expression. Okay. uh, you have made a note of this, everyone? Because in 2 marks question you will be directly given, convert the given infix expression to postfix expression, or convert the given prefix expression to prefix infix expression to prefix expression. Then you need not write the algorithm and all that, right? So directly you can write this and you can convert it, get marks. In internal examinations it will be for 1 mark question. Okay, now let us take the next one, the same. I'll take what was that expression we had? Ax plus by minus cz by f plus e. So what was this? A into x plus b into y
minus
minus
C
c
into
into
Z
z
by F
by f
plus E.
plus e. Okay, now this is the left bracket, another bracket, and then another bracket. Okay, c into z, then what, divided by f, then this particular, and then plus. Okay, now what are we going to do? Let us take first, a is multiplication will come to the left hand side, then plus s come, plus will come to this left hand side, then multiplication will come to this left hand side, immediate this one, right? And then what is next one you have? uh,
Subtraction.
Subtraction will come to this left hand side,
Next.
and then we have c, multiplication will come to this, and division will come
Division.
to left hand side here, and then plus will come
Additions.
to the last.
Last.
So now tell me what comes first here. Plus will come.
Plus
After plus,
min
what is there?
minus
Minus is there. After minus, what is there?
plus
Plus is there. After plus, what is there?
multiplication.
Multiplication. Then
AX
ax, then
into
multiplication,
BY.
by, then what is there?
By
After
division.
by, division
Division.
has come,
Division.
then
Multiplication.
multiplication has come, then
CZ.
c z,
E.
then that's all. C Z, there is nothing afterwards. F, then followed by E. This is what is the prefix expression. Same. There's no is a prefix. So postfix or prefix is only the expression which can be understood by the what, compiler. So we are going to write what, we are going to write an infix expression. So once infix expression is written, when the compiler actually substitutes the values, at that time the infix expression is also converted into postfix expression, right? And after postfix expression, then the evaluation is going to be done. The evaluation again, it takes stack. So for this also it implements stack. So remember, a data structure is required for conversion of postfix infix expression to postfix expression, or a postfix expression evaluation. uh, Stack is required for us. Okay, so is this clear, everyone? So did you complete? Now I'll just randomly give this. You can convert it into postfix and prefix, right? Okay. You please convert this as homework. This both, and we'll use this tomorrow. Okay. This also you do it. A plus B into C minus D to the power of E divided by F. Right? A plus B into C minus D to the power of E. That is power symbol. Okay, right? D to the power of E. We'll do this. Tomorrow we'll continue. Okay. Two again. So many people are absent. 211, 212, 213, 214, 215, 216, 217, 218, 219, 220 are present. Anybody doesn't have doubts, then electrical can leave. 26, 27, 27 is absent. 62, 27, 28, 29, 30, 31, 32, 33, 34 is absent. 35, 36, 37, 38, 39, 40 is absent. 41, 42, 43, 44, 45, 46, 47, 48. So these people can leave if they don't have doubts. Cyber security. Cyber security can leave if you don't have doubts. Okay, 6625, 2627, 28, 6629 is absent. 6630, 6631, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47 is absent. 4. Okay, right.
In
Leave.
triple E, who are absent, sir?
Triple E 211, 212, 213, 214.
Okay, sir.
Cyber security 6227, 6234, 6240. AML 6629 and 6647. These are the students who are absent. 432.
Thank you, sir.
So anybody those who have doubts can stay back. Otherwise, you can leave. Where anybody has got doubt?